Hello everybody, my name is Daniel and my team is Patrick, Stefan, Robin, Murat and Rina. In these 2 weeks we've made a solar charger that charge our battery, and if we want we can charge our phones here. Okay, the mechanic group prepared these panel solars to be fixed on the roof, and our task was to do electrical connections between these. Now, this sketch is a very important step because in this one it's represented how we put these solar panels. We put in a parallel circuit. That means two things. The voltage remains same on all solar panels, which is a value between 15 and 12 volts, and the current increased from 1.16 amps to 6-7 amps on all. Okay, we've connected this circuit on the roof, which is on the roof, with solar charger, which is in the teacher's room here. With a cable, and because of the distance between these two locations, which is about 15 meters, we've used a cable with 4 wires, 2 for plus, 2 for minus, because we want lower resistance and minimal losses.
So hello, this is basically our electrical device that you can see in there in the solar charge case. That is the datasheet that we use with a few modifications. The solar chargers come through there, and they have a voltage of 20 volts and 6 amps. Because of the 6 amps, we use 2 fuses, each 10 amps. And this is the input where the car battery goes in. The car battery has a voltage of 12 volts.
The first device I show you is our Arduino microcontroller. It's the heart of the board. Then we got a small sensor. It's for measuring the current of the load. Then we got the display. It shows us the information that the Arduino gives to us. And then we got 2 DC-DC converters. The first one has an output of 5 volts because it transforms the voltage down. It gives the 5 volts to the Arduino, the sensor, and our display.
And the other one is we use it basically for connecting here our 2 USB ports in order to charge our phones.
Yes, the microcontroller that we used needed to be programmed, so we did a little interface with this LCD screen. That's a sketch how the interface works. It can show 3 different screens, and we have 3 buttons under here. The home screen just shows if it's ready to charge something, if the battery is not empty. If you press the button once, you can see right now from this distance. You just see basic information about the voltage of the battery and the current. And if you press another button then after that, you get to the admin screen where you can change some parameters to control how the battery is loaded, for example. That's a little dangerous if you do it and don't know what you're doing. So if you just want to charge your phone, you just get here, take cable and plug it in, and we should see that actually works. Yes. Okay.
I want to tell you something about the advantages and the disadvantages of photovoltaic. There are many advantages, and I put some points out which I think it's interesting to know. For example, that photovoltaic is very economic because after you install the photovoltaic, you can use power nearly for free. It's very long lasting, and you don't have price variation because you are independent from the big energy concerns, which could change the price how and when they want. And you can call it kind of green energy because it's very eco-friendly. You don't use fossil fuels, and you don't have the greenhouse effect. There are some disadvantages. For example, that is photovoltaic is dependent on the sun. It means when the sun isn't shining, you can't produce energy. But that's the reason why you have extended offline times at the night, but it isn't a big problem because you can compensate it with batteries like here or something else. And at the beginning you have high costs to install, but you need much time to till it pays off.
So at last I will give you a short summary of our presentation. We developed the whole solar charger, which consists with the solar panel, the solar charger and the battery, but it can't be used unattended now because we have to do some mandatory tests, which we couldn't do now because we have in those days no sunshine and no more really time. But in the next year it will be the main task to do this mandatory test for approving operation. Another task will be to get a higher solar charge power from now 2 amps to 5 amps in the next year. And we will make the solar panels mobile that they can follow the sun, and so we can have a longer sunshine period. The longer sunshine period results to a more charge power for the charge station. The last task will be that we have to make a Wi-Fi access point for the teacher's room so that they can use Wi-Fi in the teacher room. Thank you.
Any questions to the team, or would you like to prefer a short summary in Romanian language by Daniel?